Hello everybody, my name is Yefim Dmuch and I am co-founder of rockIT Consulting company. In this presentation I will introduce to you the black box backend testing framework test.rockITizer. A few words to our company's background. rockIT Consulting is an IT company located in Stuttgart, Germany, which mainly focuses on complex integration solutions for the enterprise customers such automotive concerns, big banks, etc. In the past 5 years, our team successfully completed numerous large-scale projects in integration area. In addition to customer projects, rockIT has developed its own integration platform based on IBM integration bus and the stack of self-developed frameworks which speed up development productivity and improve quality of integration products. The next slide describes the problem area and is called integration challenges. The modern integration landscapes are very complex. They involve a variety of protocols, many data formats, and numerous backends and software products. The lack of integration testing frameworks is the problem which forces the customers to develop their own solutions, which is quite expensive in its maintenance. The customers which do not have such solutions are forced to make the tests manually, which also impacts the productivity. Our estimate is that the productivity loss lies by 30% because of the numerous vendor protocol-specific tools involved. Also, the lack of tools has an impact on quality. For example, the changes were not communicated by the partner and are discovered only on the integration environment. Or the technical release has replaced the feature and nobody found that this feature is no longer exists because of the lack of the regression testing. Another major challenge in integration area is the lack of technical infrastructure transparency and availability of business APIs. Often you see the status of integration layer available from logs only, or the custom deployed and developed status pages covering only the availability of the endpoints, but not the availability of the business functions. Also, we have to keep in mind that the complexity of the integration landscape increases over the time, and with it also the manual test effort and the costs. So the test.rockITizer addresses the challenges and introduces the one-stop solution for the integration testing, which boosts productivity and improves the quality of the integration products. So what is the main idea behind of the test.rockITizer? Basically, the idea has been taken from the industry quality control systems. So there you have the production line tracked as a black box, whereby the master samples get compared with produced samples, thus assuring the desired product quality. So we have basically the production line here, where we get thrown the parts and we are awaiting out of it the house. So basically on the first phase we make the master, we produce the masterpiece or master house, and the second phase we describe the restrictions. House must exist, the color must be okay, the form needs to be right or correct, and positions must be correct. And the third phase is our quality control phase, where the production runs and we just make the comparison between the produced samples and our master sample. So this is the same way test.rockITizer works. It is the externalized quality control tool for the testing of any integration environment. It treats the integration environment also as a black box, and it keeps you informed basically on all suspicious changes in the system behavior. So once again, test.rockITizer works with the payloads. So you provide the inputs, you get outputs, and you create the quality profiles which are comparing the master outputs with your regression phase outputs, so with this phase 3 outputs. This is the big idea of test.rockITizer. With this simple thing, it enables the control of the integration environment of any complexity. So some words about the technology behind and the core features of the test.rockITizer. So test.rockITizer is written in Java and works with the Maven and JUnit frameworks. Among the core features, or the main core features, are that test.rockITizer is a black box backend testing tool. It is completely or fully externalized. You don't need code changes on your side. It is open source, supports regression testing and continuous integration, including surefire reports. It has seamless integration in any Java IDE. The binding of the test.rockITizer is very simple. The binaries are available on the Maven Central. It has very powerful CLI command line interface. The main logic, as described in the big idea slide, it is record replay with post assertion modes. The payloads can be written via the various connectors or built-in connectors like HTTP, MQ database, and the payloads can be asserted with two major types of assertions. The first assertion makes the comparing of the payloads, and the second type of assertion checks the backends directly. For example, like database assertion, there is check the entries in the database if they match the profile. Test.rockITizer has a declarative test ban concept and environment-dependent configuration for connectors and the payloads. So once written, it runs everywhere. It has extendable connector and plugin architecture. And what's also very important, there is a built-in support for multiple database, data sources, key stores, queue managers, etc. So the unique advantages of the test.rockITizer are the boosting of the productivity for developers. So they don't need any external tools like SOAP UI, DB viewers, MQ tools, whatever. And the tool also enables the test-driven development approach for integration landscapes. For example, we are developing against the desired targets provided by the business side. So this is the information regarding the technology core features and unique advantages. So a few words to the lifecycle of the test.rockITizer. The lifecycle has two major phases: the configuration and regression testing. In order to prepare your test suite for regression mode, you must complete the configuration and record the samples, executing the following steps. The first one is creating of your test plan. The second, configure connectors and data sources. After that, you need to create your execution plan, which is implemented as a JUnit starter. Then you start your test suite in record mode in order to get the samples recorded. When the samples are recorded, you need to check if they are valid and meet the business requirements. And then update your JUnit starter with assertions quality profiles for the outputs for the step 4. After record phase is completed, you put your framework in the replay regression mode and let it run on desired environment. As mentioned previously, test suite has a Maven project structure with the POM XML having single test.rockITizer dependency with the binaries published on the Maven Central. So you can see here on the right side the project structure. It has the test plan or master test plan. What is very interesting here to see this output folder. So this is where the reference results are stored. Then you have two configuration files, resources YAML and test cases YAML. Resources YAML has the connector and data sources configuration and is environment dependent. The test cases YAML is an auto-generated file which is generated from the test plan here above from the file structure. The replay files are stored in the target replay folder here. And this is basically the same file structure with its own outputs, and its payloads are being compared between replay outputs and the master data outputs during regression testing phase. In the next slide, you can see the project structure overview. In the overview, you can see the test plan in the middle, which is stored under resources as a file folder structure, and another file test cases YAML, which is auto-generated from the folder structure here from the test plan. So this is the mirrored YAML structure. At the bottom you may see the execution plan. It is implemented as a JUnit with the same name as the test case, and with the logic of the order, step order, timeouts, and the assertions. And on the left side, you can see the resources YAML. This is the environment-dependent configuration of the connectors and data sources. Here you can see the logical link between execution plan and test case name. Due to convention, the name of the execution plan must be equal to the test plan folder. The next slide shows you the logical link between execution plan and the test step. The order of execution and the sleep times are controlled by the JUnit starter. Project structure, connectors. Connectors are the folders which are stored under the test steps and follow the special naming convention. Connector type .id. The connectors do not have any direct link from execution plan, as all connectors of the submitted step are being processed automatically based on their type, configuration, and payload availability. Currently, the following connectors are available: HTTP, MQGet, MQPut, dbget, dbput, fileget, fileput, filedel, scpput, scpget. Each connector on the file system has its own resources YAML configuration as shown on the slide. Okay, now we come to the very exciting part, working with assertions. And it is not only exciting, but it is also essential to understand it. As mentioned previously, there are two phases, record and replay. Each of these stages has its test structure, including output folder with process result acquired by get connectors. The execution plan in replay regression mode compares the intermediate outputs with master outputs based on configured assertion. In this example, you can see the XML Unit Assertion, which makes the deep comparison of the XML-based payloads. Currently, the following assertions are available: file exists assertion, XML assertion, CSV assertion, fixed length assertion, DB assertion. File exists assertion runs automatically and ensures that the number of output files results are identical for master and regression runs, not less and not more. The most assertions are working with the recorded replay payloads, but DB assertions works differently, going directly to the backend and checking that the provided SQL returns the predefined value. All tests are written as JUnits, thus can be executed in the different ways. From IDE, you can start it with the JUnit starter. You can use also the built-in Maven plugin, as also the standalone Maven installation, and the last possibility to start the JUnit is our command line interface. So here you see the output, the console output of such tests. So basically you see here the test name, you see the recorded and replay folders, the current mode, so it is in regression, and then the steps executed. The before step is a preparation step. Then we have the JSON put message written to the connector. So the HTTP connector is read-write connector. It writes and reads also the response. After that, the database is checked. So this is a special application logic that the web service writes the entry in the database. And after that, and because this is a replay mode, the assertions are being started. So this file assertion, which checks that the files are existing. Here below is the file assertion, and above there is an XML assertion. So the payload, the first what is checked is the JSON payload. There are some fields to be ignored. And the second is the database response extracted as an XML and checked also via XML assertion. The seamless IDE integration is very important. So on this slide, you can see the integration in Eclipse Ide, including the JUnit starter. So here is all the tests have been triggered with the results, and in the console you can see the output of the tests. As mentioned in the feature list, test.rockITizer has a very powerful command line interface. So this is a list of the commands it supports. The most interesting for us probably the run command, which executes the test. Sync command synchronizes the file system structure with the configuration files. And the validate command checks either the configuration and the test case are synchronized and configured. So no placeholders, no dead folders, the connectors with payloads do have payloads, and so on. So what is the right place for the test.rockITizer within the continuous integration lifecycle? You may use the framework in two ways, or in both ways. The first one is the local environment test or developer test. This means the developer implements the code, deploys it, and then start the test suite in order to ensure the product quality. And the second place where you would use it is the Jenkins pipeline as the final quality gateway in order to ensure the overall product quality. The one-line Jenkins integration could look like here, is presented on this slide. So you just basically use the Maven starter to trigger the JUnit tests, and the Surefire plugins are parsed and visualized here by the Jenkins. So what is the test.rockITizer? Test.rockITizer is a one-stop tool for integration, development, and testing. It is flexible. Test.rockITizer is an external framework which can test the integration environment of any complexity, treating it as a black box. You don't need any source code changes. There's no technological binding or any limitation in this sense. Test.rockITizer enables full control and transparency in the integration area. It is backend-testing framework with automated result comparison between current test snapshots and recorded master results. Test.rockITizer keeps you informed on any suspicious change in your integration environment. It is productivity booster. Test.rockITizer boosts the integration development process, providing all-in-one test solution, making the usage of external protocol or vendor-specific tools obsolete. It enables test-driven development. You can provide from business side the target samples and develop against them. It is open source and it is easy to extend and has variety of built-in connectors and assertions with a very comprehensive configuration. In order to start it, you can check our GitHub page. It has the source code and the very good documentation, including quick start guide, introduction, and the detailed explanation of the functionality and features. There is also the test project or sample EEB project and the related test suite for it. In case of any question, don't hesitate to write us on test.rockITizer at rockIT.consulting. I hope you enjoyed the presentation. Thank you for watching it. And don't forget to subscribe to our channel, as we will publish more videos on integration topics and on our tools. Okay, thank you for your time. Bye-bye.